Today we're going to talk about graphing sine functions, and so we're going to start with the parent function, y equals sine of x, and so just remember this is your parent function. And so we're going to take these values straight from the unit circle, so if you were to evaluate sine at the angle 0, then you would get 0. If you were to evaluate sine at the angle pi over 2, you would get 1. If you evaluate sine at the angle of pi, you get 0. If you evaluate sine at 3 pi over 4, you get negative 1, and at 2 pi you get 0. And so remember, sine is the y value from your coordinate pairs. And so then you just connect with a smooth curve and some arrows. And so you can kind of remember a pattern here. So like there was a pattern with cosine, there's also a pattern with sine. So you're starting in the middle, then you're going up, back to the middle, then you go down, and then back to the middle. The next one we're going to look at is y equals negative sine of x. And so if you remember from we were graphing cosine, the negative in front here tells us that we are reflecting over the x-axis. And so we still will start in the middle because that point's not going to change. But then instead of going up next, we're going to go down next, back to the middle, and then up, and then back to the middle. You could also look at this because if we were to compare it to our parent function, which I'll draw in blue really quick for you. That's your parent function, and so this point here reflected over the x-axis, and this point here reflected over the x-axis. Next we're going to look at y equals sine of x plus 3. And this plus 3 means that we're going to move up 3. And if you remember from yesterday, then that means that we have a midline at y equals 3. And so I'm going to draw our new midline up at y equals 3. And so now we're going to draw the graph of sine using the same pattern. So we're going to start at the midline at 0, and then we're going to go up, back to the midline, down, and back to the midline. And then you just connect with a smooth curve, and you have your graph. And so if I were to draw in our parent function really quick, you can see that all of these points just shifted up 3. The next function is y equals sine of x plus pi. And so this plus pi, remember from yesterday, gives us a phase shift, which means we move left or right, and it's always opposite. So it's going to be moving left pi. And just remember that's called a phase shift. And so if I shift left pi, usually we start on our x or y axis right here, but we're going to shift left pi. So we're actually going to start right here now instead. And so everything will shift over pi. So like now this pi over 2 would be shifted over to right here at negative pi over 2. Pi would be shifted over to 0. 3 pi over 2 would be shifted over to pi over 2. And 2 pi over 2 would be shifted over to pi. And so one thing that's actually important to note is that if you were to break where all of our points are, they're broken into 4 sections, and that's because there's 4 quadrants in the unit circle, so it's broken into fourths always. So now we just graph our function using our pattern. So we start at the midline, then we go up, back to the midline, down, and back to the midline, and connect with a smooth curve. That was not the best. There you go. And so if I draw in our parent function really quick, you'll be able to see how everything is shifted over pi. So everything went left pi. Next is y equals sine of 1/2 x plus pi. And so if you remember from yesterday, you have to factor out that b value of 1/2 right here. So we're going to write a different function with that factored out. So y equals sine of, factor out the 1/2, and then x plus. And so you're going to do pi divided by the 1/2. And if you were to do pi, I'm going to write pi over 1 divided by 1/2. You keep this the same, multiply and flip, so you end up getting 2 pi. So that means that 2 pi will go right here. And so we have this 1/2 b value here. So b equals 1/2. And so therefore to find our period, remember that period is equal to 2 pi over absolute value of b. And so you get 2 pi divided by 1/2, which would actually end up giving you 4 pi. And then this plus 2 pi here means that we're going to move, that was a really ugly E, left 2 pi. Alright, so I'm going to start by just drawing my shift left 2 pi. So we're going to go from 0, left 2 pi, which means we're going to start over here at negative 2 pi. Now our period is not 2 pi this time, it's 4 pi. So what we're going to do to find out where this ends is we're going to do negative 2 pi plus 4 pi, which actually gives us positive 2 pi. So that tells us that we're going to go all the way over to here to end our graph. And so we want to break this into fourths. And so if we're going 4 pi, if we were to do 4 pi divided by 4, we would get pi. So we can make a little mark on our graph every pi amount. And so that's where all of our points will fall. So now if we graph this, we still follow the same pattern. So we start at the midline, then we go up, back to the midline, down, and back to the midline, and then you connect with a smooth curve. So then the next one is going to be y equals negative 1/2 sine of x. So this negative 1/2, that's our a value. So a equals negative 1/2. And we want to remember that our amplitude is equal to the absolute value of a. So in this case, it equals positive 1/2. And so if we were to graph this, that means that from our midline, which is at 0, or the x-axis, we're only going up 1/2. And down 1/2. You can draw a dashed line if you want there. It's up to you. Usually I'll do a dashed line. Just easier to do a full line on this. And now you just follow your same pattern. And so we're going to start at the midline, and then we go up, midline, down, midline. And then you just connect with a smooth curve, just like that.